Okay, so to figure out what the missing one is right there, all we need to do, I just hit the wrong button. Hold on. There we go. I meant to hit this one. There we go. So figure out what the probability is that x equals 4. So in other words, what's the probability that somebody in this class has 4 siblings? We would need to add all of these and subtract from 1. So as far as this goes for work, you do need to show that that's what you are doing. So you need to show that you are going to add them all up and subtract from 1. So for example, 1 minus, I'm going to add those all up. 0.2 plus 0.425 plus 0.275 plus 0.075. That's going to give me my required probability. So like on an AP exam or on one of the exams that we do in here, if all you do is write the answer, you will not get credit. I realize that you're really going to do it on your calculator. I mean, that's just what I'm doing, typing it all on my calculator. But part of your grade is explaining and showing what you are doing. So it's the communication piece. So you are graded on the accuracy of your response, but also on the communication. That's literally the beginning directions on the AP exam, that you are graded on the accuracy of your calculations and answers, but also on the communication. Okay. This is the one chapter that we've done so far, this one unit, where there's a lot of calculations. Yeah, a lot of them are just done on the calculator, but there's still a lot of calculations to do. So this is Lovett and I are trying to figure out the best way for us to do your next exam. AP Classroom worked great for Unit 3, but this is not that fun to type in on a computer. So bottom line is this chapter, I don't want you guys typing on a computer, especially if you're going to be drawing Venn diagrams and tree diagrams and all of that stuff. It's going to be a mess if we try to do this on the computer. So we're working on that. We want you to have the option. That's kind of why we tried that exam.net. So I think we might end up doing it that way because you have the option of scanning from a paper. Okay, part B. What's the probability that x is less than 3? Oops, I did not do that correctly because 3 is not less than 3. Less than 3 are those three values, 0, 1, and 2. So I need to add up those 3 probabilities. Or you could add those 2 up and subtract from 1. So whichever way you do it, you just need to show me a valid calculation for all the values of x that are less than 3. So 0.2 plus 0.425 plus 0.275. And yes, I realize that that's an easy calculation and it's pretty intuitive. But you still got to tell me what you're doing. It's 0.9. So 90% of the class has less than 3 siblings. Okay, C, find the probability that a student chosen at random has at least 1 sibling. Now, this one is not that bad to do from the table because the opposite of at least 1 is 0. But look, here's at least 1. These are all the people that have at least 1. So yeah, I could add those 4 numbers up. It's not that bad. But if this table was bigger than 0 through 4, and we were looking at, 0 through, 50 for a specific probability model, you would not want to add up all of those choices. It is much easier to take 1 minus that. So I want to encourage you that when you see at least 1, you remember that that is equal to the probability, 1 minus the probability of none. So 1 minus the probability that somebody has no siblings. So 1 minus 20% of the class were only children. So that means 80% or 0.8 had at least 1 sibling. It's the easiest way to do that one. Okay, the mean. From a table, we find the mean of X. It's also called the expected value, by taking the first value in the table, 0, multiplying it by the probability, plus we take the next number, we multiply it by its probability, plus we take the next number, we multiply it by its probability. It is okay if you show this with a nice little dot, dot, dot that says, etc. And then I'm going to end with 4 multiplied by 0.025. That's really what we're going to do. So we're going to do that times that, that times that, that times that, that times that, that times the 0.025 that we figured out in part A. And then we're going to add them all up. So if you don't want to write every single number down, it's okay if you just write dot, dot, dot. They will understand that, and I will understand that you're just saying, etc. I'm doing all of that. And then, of course, in the end, if you want to do the calculation on your calculator using the list, that's fine too. So I could go into Stat Edit, and in list 1, I can put in the values 0, 1, 2, 3, 4. Not as imperative that you do this for the mean, but I see the standard deviation is coming up as a calculation, and I definitely don't want to do that by typing in a bunch of numbers. So let's get this in here, 0.075 and then 0.025. So I think I got them all in there correctly, hopefully. So then I can go to Stat, Calc, one variable stats, list 1, list 2, and my mean comes out to be 1.3. So the average number of siblings for this class, based on all of those probabilities, is 1.3. Okay. Standard deviation. Okay. Formula is on the formula sheet, so you don't have to memorize how to do it, but this is how we find the standard deviation. It's a big, long square root. We take the first number in the table, 0. We subtract the mean. We square it. We weight it by its probability. And then we do that for the second number in the table. We square it. We weight it. And then I'm going to do my favorite dot, dot, dot here. And I'm going to do this all the way until I get to my last entry in the table. Subtract the mean, and I weight it by a 0.025. Okay. Work. You need to show the setup of the equation here, of the formula. The formula is given, both this one and that one, but you need to show that, yeah, I know how to put the values into the formula, but I do not want to enter all of this. That's way too many numbers and parentheses, and it's really easy to make a mistake. So I am just going to do that, which is the one variable stats. And I can see that my standard deviation is 0.954. So even though I'm not going to type all of that in, I understand how that formula works. And if you go to formula sheets, you will see, come on, there we go, that both of those formulas for the mean and the standard deviation for a discrete random variable are right here. So the mean is you take each x, you multiply it by its probability, and you add them up. For the standard deviation, big old square root, you take each x, you subtract the mean, you square it, you multiply it by its probability, and then you add them all up. You do that for each value in your table, okay? So both of those formulas are there. It even says discrete random variable. Here's the mean, here's the standard deviation. You will always have access to that when you're taking a test. So no need to memorize that. But it is important that you understand how to put the values into those formulas. But then ultimately, if you want to do the calculation on here using the lists, that's what I would do, just because it's especially this. That's really tedious. Okay. There were two questions, like I said, from the assignment. And I just need to find where my tabs are, because I got the information down, but I need to look at the actual questions. Okay, so first one was about insurance. So it said there's a company, insurance company, they're going to put together an insurance policy. The insurance policy costs $120. So if you decide that you want to get this insurance, it'll cost you $120. But then the insurance policy will pay you $12,000 if you have a major injury. And it says in here that that's an injury that results in you having to be in the hospital. The chances of that happening, they calculate that the probability of somebody having a major injury is 1 out of every 2,070. Policy will also pay you $4,000 for a minor injury. And they calculate the chance of that to be 1 out of 466. So part A says create a probability model. That's a table with probabilities to represent the profit for the company. So let's let X equal their profit. And then we'll write the probability of X down here. So profit, the company sells a policy for $120. If that person doesn't have any injuries, the policy is the profit. So in other words, the company just made $120 if the person who buys the insurance policy does not get injured. Okay. It's also possible that their policy holder has a major injury. So the person pays $120 for the policy, but the company has to give them $12,000 because of their major injury. So the company could lose $11,880. Chance of that happening is 1 out of 2070. And I know that in the book, it said to round that to 4 decimal places. So I don't care if you put it in fraction form or decimal form, but it did say to round to 4 decimal places or 6 decimal places. So I will do that. So this is 0.000483. Okay. Not fortunately, you know, people's chances of having a major injury are quite low. Okay, company could pay $4,000. That means they get $120 from the person who buys the policy, but they have to pay that person $4,000 because they had a minor injury. So that's a negative profit of negative $3,880. Chance of that happening is 1 out of 466. And again, if we do this to 6 decimal places like it said, that's what that would be, to 6 decimal places. That leaves us, these are the only 3 things that can happen. Either the person buys the policy and does not get injured, they buy the policy and have a major injury, they buy the policy and get a minor injury. There's only one value left here, but we know that all of these have to add up to 1. So I'm going to do 1 minus those values there. And I end up with 0.997, well, I'll do 6 decimal places like it said. 7.371. Oops, I only did 5 decimal places here. So this should be 4.6 if I read the instructions. Okay, so that's part A. Part B says find the expected profit. Expected profit is the mean. So the expected profit for X, also called the mean of X, would be that times that, that times that, that times that, all added together. So I'm going to take 120 multiplied by 0.997371 plus negative 11,880. Multiply that by 0.000483 plus negative 3,880 and multiply that by 0.002146. Okay, that's going to get me my expected profit. And because it asks for the standard deviation, this is not so bad. I don't mind entering that in the calculator, but I don't think I really ever want to enter a standard deviation formula into the calculator just because there's just too many parentheses and exponents and too easy to make a mistake. So I'm going to go ahead and put all of this probability model into my two lists. So I got 120, I got negative 11,880, and I've got negative 3880. And then I've got 0.997371 and 0.000483 and 0.002146. And then we can go to stat calc, one variable stats, calculate, and there is my mean. So $105.62. This is in dollars because that's their expected profit. So overall, this company profits $105.62 for every policy they sell. Okay. They have to calculate this because that's how they determine how much they're going to charge for their policy. If they charge too little for their policy, they'll end up with a negative profit here and they'll go out of business. There are people called actuaries who, get a degree in math or in actuarial science, and their job working for insurance companies is figuring all of this out. They have to look at all of the tables of data and figure out, well, how likely is it that someone gets into a major accident? How likely is it that someone gets into a minor accident? And they advise the insurance companies on what they should sell all their different types of policies for. So this actually is, a very important job for insurance. They have to know how much to charge in order to make a decent profit. Because if this happens too often, they're going to go out of business. They're not going to have the money to pay out for every, accident. And sometimes that happens. Okay, standard deviation of X. You can call it either way. Standard deviation of X, standard deviation of X. I'm not going to write the whole formula out. I'm just going to tell you what it is. It's $321, basically even. That does not sound right. That's not the answer that the book is telling me, but that's what I'm getting. Actually, the answer in the book, well, this would actually, if you round, this would be $322. I think the book is wrong. The book says it's $6.53. There's no way the variability of this is $6.33. I mean, look at how varied we go from negative, almost negative 12,000 to positive 120. There's no way the standard deviation is 653. And I got the same mean that they did. So I just think that's a mistake. So if that was, if you tried to do that one and it was telling you that was wrong, I apologize, because there's no way that's $6.53. So, and if I got the mean right on here, obviously I got the standard deviation right on there too. Okay. The other question was about the coffee and donut shop. Easily the hardest problem on the assignments. Okay, this is combining random variables. They tell you that we have a coffee shop that sells coffee and donuts. Both of their sales for coffee and donuts can be modeled by a normal distribution. Technically, these are discrete because, you don't really have an infinite number of choices for the number of cups of coffee. You can't sell 340.3 cups of coffee, but there are so many choices here. We would not want to do a table like this for all the different number of cups of coffee they could sell. So even though it's technically discrete, we are going to model this with a continuous random variable using a normal model. So part A says the coffee shop is open every day but Sunday, assuming that day to day the sales are independent. That's a big assumption because usually you have, repeat customers. So, someone might go to the donut shop, every day during a week. So they might not really be independent, but we're going to assume that they are independent. What's the probability that he sells over 2,000 cups of coffee in a week? So this is the average per day. So we need to look at what's going to happen in a week. Okay. A week is 6 days because there's no Sunday. It says they are open every day but Sunday. So the mean for the week. Okay. So the mean for the week is going to be the average number of cups of coffee sold on Monday plus the average number of cups sold on Tuesday plus the average number of cups sold on Wednesday and Thursday and Friday and Saturday. So we're basically going to add 340 for all 6 days. 1, 2, 3, 4, 5, 6. Of course, mathematically, you can just do 340 times 6. And I get, for the week, they average 2,040 cups of coffee. Okay, the standard deviation for the week. The reason I did this is because we now need to do the same thing with standard deviations. Standard deviation is 23. First day, the standard deviation was 23. Second day, it was 23. Third day, it was 23. Fourth day, it was 23. Fifth day, it was 23. Sixth day, it was 23. I have 6 standard deviations here. Can we add them together? No, we never add standard deviations together. What we can do is square them. That means make them variance. And then we'd have to square root them. Okay, we cannot just multiply that by 6. They're not saying, suppose one day he sells 6 times as much coffee as normal. That would be, yeah, let's multiply the number of cups of coffee by 6. That's not what we're doing. We're combining 6 independent days. So we're actually adding 6 days together. So 23 squared, do all of that and square root it. I get 56.34. So I now have a new normal model. There's my mean, there's my standard deviation. So here's my normal model. The mean is 2,040 cups for the week. The standard deviation of this normal model is 56.34. And we can now find the probability that he sells over 2,000 cups. 2,000 would be over here somewhere. And we're looking for all of this. And since it is a normal model, you can type this into your calculator using normal CDF. Okay, so if we do normal CDF, my lower would be the 2,000. My upper would be just a really, really big number. And my mean is 2040. And my standard deviation is 56.34. So I go to second normal CDF, 2,000, huge number for my upper, and 56.34, paste, and I get 0.7611. Oh, good, that's what they got. Okay, part B. Okay, so on part B, it says, what's the probability? No, it says if he makes a profit of 50 cents on each cup of coffee, 40 cents on each donut. So let's say he's 50 cents for coffee and a profit of 40 cents for a donut. Can he get a profit of over 300? So can he profit greater than $300 in a day? Or how likely is it? So each cup of coffee is 50 cents. So my mean profit is going to be 50 cents for a cup of coffee plus 40 cents for a donut. That's going to be 50 cents. Coffee, there were 340 average. Donuts averaged 140. Remember, whatever you do to the variables, you do that to the means. So 0.50 times 340 plus 0.4 times 140. His average profit is $226 per day. So how likely is it that he can make over $300? Well, we don't know the answer to that until we know what the standard deviation is. We have to know how much this will vary by. So we do have to calculate the standard deviation. Okay, so standard deviation for the cups of coffee. Okay, I know that I can multiply standard deviation by 50 cents because standard deviation, when you multiply by a constant, you multiply your standard deviation by that constant. So I can take my standard deviation of my coffee and multiply it by 50 cents. I can multiply that by a constant. Now I have two standard deviations here. This is the standard deviation for the profit from coffee. This is the standard deviation of the profit from donuts. I want to combine them, but I can't do that because we cannot add two standard deviations together. So we have to square them and add them and take the square root. Okay, so we have to turn them into variance. And this is tricky. I mean, look at that calculation there. It's really easy to not realize that that's what you have to do. So 0.5 times 23, then I square that, plus 0.4 times 10. I square that, and I get 12.18. So how likely is that? Well, you can put it on a graph and you can actually find the probability, but I could also calculate a z-score here. You guys remember z-scores, right? So 300 minus 226 divided by my standard deviation. This is a z-score of 6.08. So you tell me, is that very likely? Do z-scores of 6 come up very often? No. Remember, 99.7% of values on a normal model lie within 3 standard deviations of the mean. So he should pretty much never expect to get more than $300 in a day. That's extremely, extremely unlikely. You can calculate the probability here using normal CDF, but it's going to be practically 0 if you do that. Okay. And then part C, the last one, says, what's the probability that on any given day he'll sell a donut to more than half of his customers? So we want the number of donuts to be more than half the amount of the coffee. So it says, what's the probability that the amount of donuts he sells is more than half the amount of coffee? So it says, what's the probability that he'll sell a donut to more than half of the coffee customers? Okay, so I could bring this over here, and this is the same as that. So I could really find the probability of this being greater than 0. So on a normal model, I can calculate the mean of this. The mean of a donut minus half of a coffee is 140 for the donut minus, it's a minus, 1/2 times 340. That'll give me the mean for the normal distribution. So I'm just doing this, donut minus half of the coffee. Standard deviation. Standard deviation for one donut is 10. Standard deviation for half a cup of coffee, I know it's not really half a cup of coffee, but it's half of the number of cups of coffee that are sold, is that. So here's the standard deviation for the number of donuts. Here's the standard deviation for half of the number of cups of coffee. We want to combine them by subtracting, but we never subtract standard deviations. We never add standard deviations. All we ever do with standard deviations is square them, add them, and square root them. So this will be your new mean, this will be your new standard deviation, and then on your normal model, you can figure out the probability of being greater than 0. So I don't know where 0 is going to come in here. This is 140 minus 0.5 times 340. The mean is negative 30. So our mean here is negative 30. So 0 is somewhere out here. Okay, so I'll let you guys finish that up. But you calculate the mean here, which I just did, finish the calculation of the standard deviation, and then you can use normal CDF to figure out the area to the right of 0, because we're looking for that to be greater than 0. Okay, and this easily was the hardest problem on the book work, in my opinion. I mean, you might not agree with me, but that's just my opinion. Okay, so StatsMedic. Our StatsMedic today is not real long, so we should be good finishing this up before the end of class. And I did get it to post on Schoology. So you can get it from there, but I also emailed it to you. Yeah. Yes. Okay. So here is our StatsMedic. Okay, today we're talking about basketball. Specifically, the 2005 conference and USA basketball tournament. So college basketball here. Memphis trailed Louisville by 2 points. So Memphis was behind by 2 points. At the buzzer, Memphis's team member, Darius Washington, he attempted a 3-pointer. He missed basically because he was fouled. Okay, so he missed the 3-point shot. He was fouled. That means that someone from the other team basically purposely bumped into him to make him miss the shot. So when that happens, he's allowed to go to the free throw line to take 3 free throws. So each made free throw is worth 1 point. So our question is, was that a smart strategy for Louisville? So was it actually a smart decision to foul him? Okay, so we need to look at, well, what could have happened. So he takes his 3 free throw shots. What are all the different ways 3 free throws could pan out? For example, he could make the first one and then miss and then miss. So it is possible that he makes all 3. I'll use check marks for making the shot, and then we'll use X's for missing the shot. Okay, that's possible. He could make all 3. Okay, he could make 2 of the 3. So like this. He makes the first 2 and then he misses. But that's not the only way to make 2 shots out of 3. It could be he makes this one and then misses and then makes that one. Or it could be that he misses the first shot and then he makes the next 2. But that's all the ways that he could make 2 out of the 3. So he could make all 3. He could make 2 out of the 3. He could just make 1 out of the 3. So let's look at what those could look like. He makes 1 out of the 3. Makes the first one and then misses the next 2. Maybe he makes the second one and misses the other 2. Maybe he makes the third one and misses the first 2. But that's it. There's only 3 ways that making 1 shot out of 3 will pan out. And then the next option is he could miss all 3. So there are 1, 2, 3, 4, 5, 6, 7, 8 different possibilities of what can happen. Someone goes up to the free throw line and makes 3 attempts. There are 8 outcomes. There's 8 ways that it could work out as far as whether you make the shot or you miss the shot. So we're going to analyze these 8 different outcomes. So Darius Washington was a 72% free throw shooter. So that means that the probability that he makes the shot, so the probability that he makes any shot is 0.72, and the probability that he misses any shot would be 0.28. Okay, so we're basing that off of his stats. So he, at that time, he was a 72% free thrower. So we're going to assume that every time he steps up to the line, his chances of making the basket is 72%. The chances that he misses the basket is 28%. Okay. We are also going to assume that all of his attempts are independent. It could be argued that they're not, because maybe he makes the first one, his confidence, grows a little bit, the cheers from the crowd, since this is the last, shot of the game, affects him in some way, and maybe his chances of making the basket, changes. Who knows? But we're going to assume that they're independent, meaning that every shot he makes had a 72% chance. Every shot he missed had a 28% chance. Okay, so if we take a look at this, that means they win the game. Okay, for Memphis to win the game, they were behind by 2 points. How many of the shots does Washington need to make? He has to make all 3. The only way that Memphis is going to win the game, because they were behind by 2, is if they make all 3 shots. So the only way this is going to happen is they have to make, or he has to make all 3. So in other words, this is what has to happen. So he has to make the first shot. He has to make the second shot. They're independent, so we can multiply them together. He has to make the third shot. So to make all 3 shots, 0.72 times 0.72 times 0.72. Yes, I know you can use an exponent, but that would be 0.373. We'll just do 4 decimal places. Okay. So by fouling, there is a 37% chance that Memphis will still be able to win the game. So they got fouled, leaving a 37% chance of Memphis winning. Okay. To lose the game. Okay. To lose the game, they have to make less than all 3. So in other words, one option is they will lose the game if they miss all 3. Okay, if he misses all 3, they lose the game. So that's one possibility, is basically this one over here. If that happens, they will lose the game. So the chances of that happening are 0.28 times 0.28 times 0.28. And I am leaving space on purpose because there's more to this one than just the 0.28s. So this comes out to 0.0220. Okay, that's the chances that he misses all 3. However, if he only makes 1 out of the 3, so if this happens here, they also lose. So they can lose if he misses all 3, but they will also lose if he makes only 1 out of 3. Okay, so the other possibility is that he makes 1 out of 3. So we got to look at these here. Okay. If he makes 1 out of 3, that means, for example, check XX. Check is 0.72. XX is 0.28 times 0.28. So this one, X check, or check XX, is 0.72 times 0.28 times 0.28. My next option is X check X. This one is going to be 0.28 times 0.72 times 0.28. Mathematically, is that the same thing as this? Yeah, we're just multiplying. We're just changing the order, but we're still multiplying the same 3 numbers. This is the same thing. XX check is 0.28 times 0.28 times 0.72. So these are all the same. So it is okay if I just say, hey, I'm going to multiply that by 3, because there's 3 ways that this happened and they're all the same. Okay, so that 3 is because there are 3 ways. So there are 3 ways that that happened. So if we multiply that all together, 3 times 0.72 times 0.28, I'm just going to hit 0.28 squared because there's 2 of them. I get 0.1693. So the probability he loses is these 2 combined. So you can see it's about like 19% chance there that he loses. We're going to put it in the next table down there. Okay, the third possibility is he ties up the game and it goes to overtime. Okay, he can tie up the game by making 2 shots out of 3. So all of these over here would represent he is successful enough to tie the game and it goes to overtime. So he could go to overtime or make the game go to overtime if he makes 2 out of 3. Yep, so first one, check, check, X. Check, check, X is 0.72 times 0.72 times 0.28. That's check, check, X. The next one is check, X, check. But notice it's the same thing. All we're doing is moving where the 28% goes, but it's all being multiplied. So there's no reason for me to calculate all 3 of these and add them up. It's just easier if I say, hey, there's 3 different ways. Okay, so right there, 3 ways. That's why we have the 3. So 3 ways there, 3 ways over here. So 3 times 0.72 squared times 0.28. And this comes out to 0.4355. So about a 43.5% chance that he ties the game and they have to go to overtime. And then as far as strategy goes, it would all depend on, how likely is it for Louisville to win in overtime. Okay. Now, if you take a look at what we did here, okay, every single one of these scenarios, we're basically counting the number of makes. When you make all 3, this was basically 0.72 to the third. I could have said, hey, this is just 0.72 to the third because we have 3 successes. Okay. When we miss all 3, it's 0.28 to the third, 0.28 because that's the probability of failure. There's no successes here. So there's just the failure percent right here represented, and again to the third power. When you make 1 out of 3, we have 1 success, 0.72. We have 2 failures, 0.28, which we could do squared, 0.28 times 0.28. And we got to think about how many different ways that can happen. We did the same thing here, okay? This is something called a binomial distribution. And the way that this is set up is you take the number of ways, you multiply by the probability of success. And up here, the exponent is the number of successes. You multiply that by the probability of failure. And then up here, your exponent is the number of failures. So if you take a look, that's actually what we've been doing, okay? There was only one way to make 3 baskets right here. There's only one. So technically there is a 1 in the front. And then we had the probability of success raised to the 3rd power because there were 3 successes. There were 0 failures, so this just goes away. Here, 3 ways that you can make 1 out of 3 baskets. So we had the number of ways in the front. And then we had the success, 1 success, so 0.72 to the 1. And then we had 2 failures, 0.28 to the 2nd power. Okay, now mathematically, because you're not going to want to write that down, but mathematically, we find the number of ways by doing a combination. Okay, so our combination, for example, 3 choose 1. That's the number of ways to make 1 basket out of 3. So my question to you guys, have you ever seen that before? Combination. It's something that used to be taught in Algebra 2, and I think they teach it in Integrated 3, but last year Integrated 3 got cut short, so I don't know whether you guys have seen combinations and permutations before. So if you haven't, that's all that means. It means how many ways can you get 1 success out of 3. So we know that there's 3 ways to get 1 success right here. Oh, right here. 3 ways to get 1 success. On your calculator, you can have your calculator calculate that for you. 3, you go to math, probability, and you will see the combination thing right there. And then you type in a 1. So this is basically, hey, calculator, how many ways can you make 1 basket out of 3? You can do it 3 different ways. Okay, what if I had 10 shots at the basket and I wanted to make 3 of them? So how many ways can you make 3 baskets out of 10 attempts? There's a lot of ways. So we would not want to list them all because there's 120 ways. But that's how you find the number of ways, okay? Is you do a combination and you just do that on your calculator. Successes. We had 0.72 for our success. We had 3 of them. Failure, we had 0.28 for our failure, and we had 1 of them. So this right here is basically this calculation right here. Oops, that one. That was the one. Why did I put a 3 there? We did not have 3 successes. We had 1 success and 2 failures. So that's what we were looking at. 1 success out of 3. We had 1 success and 2 failures. So that's basically this calculation right here. So we had 1 success, 2 failures. Okay. And this is called binomial. And it just means you're counting the number of successes out of a total. Okay, let's fill in this table right here. So Louisville had 75 points. Memphis has 73 points. Mr. Washington has 3 shots. The probability that they win the game, that Memphis wins the game, is right up here. The only way that they win the game is if he makes all 3 of the shots. Okay, probability that they lose. Well, that's the second stuff here. There's 0.022 plus 0.1693. So the probability that they lose is 0.1913. Probability of overtime is the 0.4355. Okay, so that's what the game looks like as soon as they foul him. So as soon as he's fouled, Memphis has a 37% chance of winning, 19% chance of losing, and a 43% chance of forcing overtime. Okay, let's say he makes the first shot. Now they have 74 points. He has 2 shots left. The chances of winning. He's got 2 shots left. He's got to make them both. So now we're looking at 0.72 squared. Okay. So after he makes the first shot, the chances of winning has gone up because he already made 1 shot. So now he's only got to make 2 now. Okay. The chances of losing the game, well, they will lose the game if he misses both of these because they'll lose by 1 point. So in order for them to lose the game, he has to miss 2 shots in a row. So the chance of him losing the game has gone down. And then, of course, we could just, subtract from 1 since that's the only possibility left. Either you win, you lose, or you tie to make to overtime. But we do know that there's 2 ways that this can happen. He has to make 1 of the shots. So either he makes the first shot or he makes the second shot, but he has to make 1 shot and miss 1 shot. And there's 2 ways for that to happen. Make, miss, or miss, make. So if he's got to make 1 out of those 2 shots, there's only 2 ways that that can happen. So we're there. So his 3rd shot. Okay. Of course, if he makes the first 2 shots, if he makes that 3rd shot, then you know that they're going to go into overtime. But let's say he's got 1 shot left. We got 74 points and he's got 1 shot left. Okay, so that means he's made 1 of his first 2 shots. Now he's got 1 shot left. Okay, can Memphis win straight out? Nope, because there's only 1 shot left. So the best they can get is 75 points. So they now have a 0 chance of winning in this scenario. So if he misses, they only have 74 points going into his last free throw. They have no chance of winning. However, there is a 28% chance that they'll lose because that's the chance of him missing the 1 shot. And if he makes the 1 shot, they tie and go to overtime. Okay? So that's just all the different scenarios of what can happen based on how many shots he has left. Now, the question here, Washington is a 40% 3-point shooter. So in other words, if Memphis had not fouled him and they let him attempt his 3-point shot, he would have had a 40% chance of making the free throw shot. So do you think the foul was a smart move? So what do you think? So if they had let him take the shot, 40% chance that Memphis would have won. They foul him. What's the chances Memphis wins now? Down a little bit. What's that? Yeah, but then we don't know what's going to happen in overtime. You're absolutely right. Yeah. Because if he missed that shot, it was right at the buzzer, wasn't it? Yeah, it was at the buzzer. So it's not like he would have had another chance. So you're right. They have the chance. This goes down, but you're absolutely right. There's a pretty decent chance that they'll go to overtime. And who knows what can happen in overtime. So the chances, this might increase the chances of Memphis winning the game. It just depends on how good each team is in overtime. So you're right. That's really what it comes down to. So far as the strategy itself, yeah, this decreased a little bit, not a lot. Is it a good move? It really does depend. Since there is almost a 50% chance, almost a 43.5% chance that they'll end up in overtime. you know, is that a good move to force overtime? Because, you know, that's a really good chance of that happening. Notice here, the chances that Memphis loses, so the chances of Louisville being successful and just winning the game is about 19%. Whereas if they let him make the 3-point shot, it would have been about 20%. So it didn't change a whole lot. So you could argue that, you know, it might not be worth the foul, but you know, there is at least a little bit of change there. So there's no right or wrong answer there, but that is a good analysis of what's going on. I don't want to go here. There we go. Okay. So binomial random variables, because this was a binomial. So the first thing you need to know is, how do you tell if you have a binomial? So we're going to look for bins. Okay, B stands for binary. Binary means there's two outcomes, success or failure. He makes the basket, he misses the basket. There's only two things that can happen. So some people just call this success versus failure. Okay, so the first thing is you got to have a binary situation. You got to only have two things that can happen. Okay, second thing is each trial has to be independent. So you need independence. Okay. N, you need a set number of trials. In our case, it was 3. He had 3 free throw shots, but you need a total number of trials that you're looking at. So a set number of trials. And the last thing is you need the same probability every time. So the probability of success has to be the same. And we would call that value P. Okay. The formula for binomial. Okay, so the probability that your number of successes is equal to, let's just say, some value K. So what's the probability of 1 success? What's the probability of 2 successes? What's the probability of, you know, whatever? How do we do this? We first have to figure out how many ways you can get your successes. So NCK. Then you got to take your probability of success, take it to the K power. How many successes are we looking for? And then you got to figure out how likely is a failure. 1 minus P is your failure rate. And you got to figure out, well, how many failures are there going to be? Well, since we have N trials and K successes, that means N minus K would be the number of failures. Okay, so N is the total number. Oops, that's total. That's the total number. Okay, and then P is probability of success. And K is the number of successes. Okay. So the number of successes we are looking for. So with our basketball, we did 1 success, we did 2 successes. I mean, we did 0 and we did 3. Those were easy. But we also did, you know, 1 success and 2 successes. So number of success, or number of trials, combination, number of successes. P raised to the number of successes, 1 minus P raised to the N minus K, which is equal to the number of failures. Okay. Now, this formula, believe it or not, is located on your formula sheet? It is right there. Okay. This right here, this parentheses NX is the same as NCX or NCK. That's the same thing. So this NX in the parentheses here, it's not a fraction or divided or anything like that. That's just a different notation for this exact same thing. So you can do that on your calculator, and then how many successes, how many failures. And it says X has to be right here. I don't know why they use X in both places. It's confusing. That's why I like to put a K right there, but it does not matter whether it's an X or a K. But that value X or K has to be a whole number somewhere between 0 and N, because N is the total number of trials. So this formula that we just did on this Statsmetic is on your formula sheet. Okay, so that formula is there on your formula sheet. So how are we doing? We're just about out of time. Okay, so on your check understanding, determine whether or not each one of these is binomial. This is what you got to look for. Are there two outcomes, success and failure? Is each trial independent? Is there a set number of trials? And does the probability stay the same every single time? If you say yes to all of those, then it's binomial. If you say no to any of those, it's not binomial. So you cannot use this formula. Okay, that is the formula that only works for binomial. Okay, so there we go. And this is due tonight because I want to get this into your first semester grade. And then the Skew the Script stuff will be due on Sunday night. Okay. Oh, and there's 2 progress checks. Almost forgot. 2 progress checks. Those are also due Sunday night. So progress check A and B, multiple choice. There's like 12 questions on AP Classroom. It's on the agenda, but make sure you also do the 2 progress checks. So 2 progress checks, Skew the Script is due by Sunday. Finish this up and get that submitted today. It shouldn't take you that long to finish that up. Okay, so we are halfway done with AP Stats, guys. We are technically a little over half because we're almost done with unit 4 out of 7 units. So, but, you know, we don't have to be picky about that. Okay, so any questions? Oops, I'm dropping everything all over the place. Okay, so let me stop the recording here.